Welcome to my channel. Today I want to show you how to find determinants of higher order matrices using very simple steps by introducing zeros along a column or along a row, and then find that determinant along that very row or column. So let me show you example. So the thing is, if a matrix already has a column that has some zeros or a row that has some zeros, then it's easier to find the determinant along that row or column. But if there are no zeros, then you can think of a way of introducing zeros, maybe in a column or in a row, and then find the determinant along that very row or column. So the topic is easier steps in determining determinants. We want to look at easier steps in determining determinants, either along a row or along a column. So let's just look at one example or two examples. And the example here is find that A if A is 2, negative 2, 6, and then 2, 0, negative 2, and then 4, 2, 12. So the question is find the determinant of this matrix. And what we know is that we can find the determinant of this matrix along any row or along any column, and the result will be the same. But for me, it's easier to find it along this column because this column has a 0, so it will reduce my working. Or along this row because this row has a 0, and that will reduce my working. And even to reduce my working further, I may want to introduce another 0 so that it may be here or here, so that this column has two zeros. Or I can introduce it either here or here, in this position or in this position, so that this row has two zeros. So I wanted to make it easy as possible for me, myself. So let me find the determinant of this matrix. I want to introduce a 0 in this position. And to introduce a 0 in this position, I want to add row 1 to row 3 to get the new row 3. So when that happens, our row 1 remains the way it is, and then row 2 remains the way it is, and then I just want to add row 1 to row 3. When I add, I'll find a 6 here, and then this plus that will give me a 0 here, and then this plus that will give me 18 here. So you can now see that this column has two zeros. So I can find my determinant along this column. So that means I'll have these two here. Remember, it's plus, minus. So that minus and this gives me that positive. And when I delete the row that has these two and the column that has these two, then I write what I'm left with. The matrix that I'm left with is 2, 6, negative 2, 18. Now I can just multiply this as 36 and this as so this becomes 2 into, so this will be 36. then this will be positive 12, which gives you, this is 48 times that, that'll be 96. That's correct. This is the determinant of this matrix. Now, there's something else you can do to this matrix again and find the same determinant. You can even factorize, so that I want you to know that factorizing has no impact on the determinant. That the determinant remains the same if you factorize. Let me show you how I would have factorized, so that I'll use that in the next example. The next example I'll be factorizing and for you to see how easy it is. Now I want to just factorize this column. When 2 is common, so I take it out. When I take it out, I'll have that the 2 that is already out times the 2 that I'm now taking out. I'm taking this 2 out, and that 2 goes into this 2. Just a minute, let me just delete this bracket because I want it to be a command to define the determinant. Now, so this 2 goes into these 2 ones, and it goes into this 6 3 times. So I've just factorized it along that column, and this other column I've not touched it. But if you want, you can also factorize this other column, but I've just chosen to factorize one column. So this will be 18. So this means I have 4 outside, and inside I have 18 plus 6. I have 18 plus 6, which gives you 96. Now, so you choose the column you want to factorize. You can even want to factorize along this, and let's see what happens. That's what happens if I were to do that. If I were to do that, remember I've already found the answer to this. If I was to factorize along that other column also, this is what I would have. I already have 4 outside. So then 2 is common here. I put it outside, I factorize it. What remains? I have 1, 3, and then this one I have -1, and then 9. So remember the first 2 was only factorizing this other column, not the whole thing. So somebody might think that I was supposed to have written here -1 and then 9. No. This one was only, I was only targeting this. You can also target a row, factorize a row and a column, or a row and a row. Now, so this is 8, and inside this bracket what I have is 9 plus 3, which is 12. And again, I'll get 96. So you can see factorizing makes our work easier, and again, introducing zeros made our work easier here. Let us look at one more example that will assist us see that creating zeros along a column or along a row makes it easier for us to calculate determinant. So the example here, that is our question number 2. It says prove that the determinant of 1, 1, 1, A, B, C, A square, B square, C square, that prove that this determinant is the same as A minus B multiplied by B minus C multiplied by C minus A. So I want to prove that this is the determinant of this. Now, for us to do this, it's easier to either create zeros along a column or along a row. And you know that we can do the determinant of a matrix can be found along any row and along any column. Now, so I'm saying it's easier for me to create zeros along this row. So I want to create a 0 in this position and in this position. Now, so what do I do for me to show that this determinant is the same as this? I have to say that I have A minus B here. So because of this A minus B, I'm seeing that column 2 has been subtracted from column 1 because B is in column 2 and A is in column 1. So my first thing I will do is I'll subtract row 2 from, no, not row 2, column 2. Subtract column 2 from column 1. Subtract column 2 from column 1. So when that happens, subtract 1 from 1, I have a 0. Subtract B from A, I have A minus B. Subtract B square from A square, I have A square minus B square. So column 2 remains the way it is, and column 3 remains. Now, so the next thing I can is, but I want to have as many zeros as possible so that my working becomes easier. So I want, again, because I can see from what I want to prove, I can see that I have B minus C. So I want to subtract column 3 from column 2. So I want to subtract column 3 from column 2 to get my new column 3. So when that happens, column 1 remains where it is, 0, A minus B, A square minus B square. Then I'm subtracting this column from this column. So 1 from 1 gives me 0. C from B, I have B minus C. And C square from B square, I have B square minus C square. So this other column 3 remains where it is, 1, C, and C square. So what has helped me is what I want to show. What I want to show has really guided me in what I should subtract from what. Because when I discovered that I had A minus B, I thought of how do I get A minus B from this, and discovered that it is this column 2 from column 1. Because subtracting column 2 from column 1, I have A minus B. That's what you see here. Then in the next step, I thought of how do I get B minus C, and discovered that I need to have, since C is in column 3 and B is in column 2, I need to have column 3 from column 2. And that's what I did here, and to have this. Now, when I reach here, I'm now ready to get the determinant along the first row. So, and then the first row, so normally we have is as plus, minus, then plus. So it would be this one multiplied by the determinant that is formed when you delete the row of 1 and the column of 1. When you delete the row of 1, that is row 1, and then the column of 1, which is column 3, you are left with this A minus B, B minus C, A square minus B square, matrix whose determinant I want to get. So I then have the A minus B, B minus C, A square minus B square, and then B square minus C square. At this point, there are very many ways I can do this. I can simplify this to be A. I can simplify this to be A minus B, B A plus B, and then simplify also this to be B minus C multiplied by, you know what this is? You know that if I have A square minus B square, somebody can write this as A minus B, A plus B. And that this one, somebody can write it as B, this is B square minus C square. Somebody can write this as B minus C, B plus C. So I may also want to write it that way. And when I write this one like this, I'm seeing that this first column would have a common term, which is A minus B. I may want to factorize that one out. And if I write this one as B minus C times B plus C, I want to see that this column 2 has a common term, which is B minus C. I can also factorize it out. So that's what I'm saying. I can have it as A minus B, factorize that out, then B minus C, factorize it out, into, and what was this? This was A minus B multiplied by A plus B, this one. So if A minus B goes into this A minus B once, and then it goes here, A plus B. What about this B minus C? This B minus C goes here once, and then it goes here, B plus C. So you can see now what we have. What we have is that I can now find this determinant and multiply by this. So let me just get this space and then do it from there. Just get us some space here. So what I have outside the bracket is A minus B multiplied by B minus C, and I hope nobody has a problem on what I've done here. Yeah, I've already said what this one is. This is A minus B multiplied by A plus B. So when A minus B is taken outside, it goes into this one once, and then it goes to what is here, A plus B. So you just factorize this part and factorize this part here. This part will be A B plus C multiplied by B minus C. So you can see B minus C will be common in this column. You can factor it out. A minus B will be common in this column. Factor it out. That's what I did here. Now, so the determinant here will be B plus C, then minus this. So we multiply along this diagonal and then subtract the result from this diagonal, the product of this diagonal. So the product of this diagonal is minus A minus B. Then I subtract it. So you can see B minus B will be 0. So what do I have? What I have is A minus B times B minus C. And this one will give us B minus A. No. B and B gives us 0. So we have C minus A. C minus A as the result. And that's what we wanted to show. Alternatively, if I didn't want to factor it out here, to factor A minus B and B minus C out here, then I would just find this determinant. Just multiply this determinant, this diagonal, and this diagonal, and then factor it out, and then factorize later. So I'll just multiply A minus B followed by this, and then minus the result of the product from this diagonal, and then proceed as below. So what I mean is that if I do not factorize this AB out and BC out, the other way that I should do it, that will give us the same result, is that I just get the determinant the same way we normally get the determinant. This diagonal, the product of this diagonal minus the product of this diagonal. So if I get this diagonal, give me a minus b multiplied by b square minus c square. But we've already said what this one is. So b square minus c square. We've already said that it will be b minus c multiplied by b plus c. So, but we shall come back to that. Then minus the product of this is b minus c multiplied by a square minus b square, which we can also factorize further. So let's just factorize further. This first bracket is s minus b multiplied by a minus b multiplied by, no, this is b minus c. This is b minus c, not a minus b. So it's b minus c multiplied by b plus c. And then minus, this one is b minus c multiplied by, we can factorize this one further. It will be a minus b multiplied by a plus b. So this we had said earlier, but at that time we factored out that a minus b was common. You can see it's common. A minus b is, what is this? Oh yeah. It's common because we have a minus b, there's a minus b here, it's here, a minus b. And then you can also see that b minus c, which is here, is also here, b minus c. So we have b minus c, and then b minus c. So let's just now factorize. Take the common terms out. A minus b is here, b minus c is here. We have a minus b, b minus c. So it's common. So a minus b, b minus c is common. So put it outside the bracket. This a minus b multiplied by b minus c would go into this b plus c times. And a minus b times b minus c would go into this a plus b times. But remember this minus. A plus b times, close the bracket. Now let's again do it. Let's factor